everybody. It's amazing to see you all today. Amazing to see you all chatting, connecting to one another. New faces, familiar faces, friends. So we're gonna have fun today. We are up for a treat, and thanks to Academia for hosting us today. Let's give them a round of applause. Hi, I'm Arina. I run a company called Evil Martians. But I wanna start with something. It's how I see what we're doing here. And nice. I wasn't sure how it's gonna play. So I think what we are doing we are connecting four distinct areas where things are happening. So first of all, there are engineers, right, learning Ruby. Then there are new companies or startups built with Ruby. Then there are big and successful enterprises built with Ruby. And then maybe the biggest part, right, is the language and the frameworks. We'll hear about some of them today. And the open source and the ecosystem. And here today, there are many people from all those different spheres, right? There are people that use Ruby, that learn Ruby, that love Ruby. There are people working in different types of companies, and there are people building out the ecosystem. And again, this can be all, the same person. But what I think is happening is that if you think about community is a way to help those different types of people in those different areas get together and build connections and help each other. For example, authors of open source need feedback and need to know that you're using it at your workplace or for your side project or anywhere. Engineers looking for a job, of course, need to find that. Companies need to be able to hire. Startups need to be able to find the right tools to solve their problems, etc. So I want this community to be this place. And I think this is happening because we have all of you extremely talented people in the room together. So thanks so much for making this all happen. Thank you. And we already have 3 events planned. So there's today's event, there's also the next event is going to be December the 3rd. So please use the link luma/sfruby. Sign up there and you will have updates for all the future events. And please come, please join, please bring your questions, use the open mic session to bring your questions, your announcements, your learnings, bring your wins and everything we got here. Also, December is a special month. I'm not sure if we're going to be doing this, but I hope maybe, oh my God, it's going to be, so what do I propose us to do next time? It's December the 3rd, hopefully before everybody's off someplace for the holidays. But maybe let's bring cookies. Do something like that and bring your holiday mood and bring your vibes, costumes. So yeah, and finally we have something planned for January already. Again, a product board, and in December we meet at Sentry. We have something at product board. We talk to 3 more companies that want to host the event, so it's pretty active. So the only thing we need is you. And with that, I'm super excited to now proceed to the back part of this, to the talks. And we have Konstantin, then Chris. But then we have a break, open mic, Brad and Jeremy. So with that, Konstantin, please take it away.
Slight technical difficulties.
Because this is a meetup, we're always gonna be reconnecting, connecting, spending time. Good luck, it's not us.
All right, everything worked. Amazing. Thank you for that introduction, Irina. Thank you for organizing these events. We used to have really good SF Ruby community back in the day when I was starting, and I was kind of on hiatus. So thank you for starting it for all of us. My talk today is on design for loose coupling in Ruby. And I think it's a topic that hopefully will be relatable to a lot of people here because it's kind of one of the only ways we have in our disposal to kind of break up really big code bases and make them more manageable. So Rails only gives you a starting point for your application. It does not tell you how to organize your actual business logic. And so result is people just kind of fill up these model directories flat and at some point maybe start creating directories and so on. And so it eventually gets pretty complicated. So I write sometimes spaghetti code. Who else here writes spaghetti code? Intentionally? Excellent. So nobody wants spaghetti code intentionally, but we just happen to do it. Now, I'm sorry I had to put this wordy slide with the definition, but in my own words, essentially, loose coupling is when you have very few connections between high-level abstractions modules and lots of connections within it. You can call it tight coupling, tight cohesion, high cohesion, loose coupling, low cohesion, and so on. Lots of synonyms, but the point is the same. If you have connections, messages passing all over the place, you have a spaghetti. If you don't have it somehow constrained. So with this definition out of the way, when you begin your application, Rails or not, you're just going to tightly couple your code no matter what, because why not? Surface area is small, abstractions are unnecessary. So in the beginning, I think it's entirely fine. This is kind of maybe not exactly perfect visualization of how your spaghetti code would look like, but you can imagine. After a while, however, things get harder with exponential complexity because it starts to look like this. And so what is the alternative? The alternative is you can design your app as a set of interoperating modules or subsystems with clear boundaries and enforcement capabilities. You don't do this from the beginning, of course, but it might look like this, where you have a module with lots and lots of meaningful connections inside, maybe direct access, maybe direct database access, but then between these modules, these thick arrows represent kind of API calls through a public interface that has been announced by this module. So you start thinking about it when your app no longer fits in any individual head. Or maybe you can think ahead knowing that this is going to come to you. And in that case, if you're building an application that you know is going to be complex, you might start by thinking, how can I partition my models into models that interoperate within, but don't talk much to the outside system. So another reasons to start thinking about it is when there's just too many cooks in the kitchen, or when developer productivity just screeches to a halt. So why do we care about this? What do we get from it and what do we lose? And just a step, I want to step a little bit back, as I usually do. I'll kind of imagine most people here write commercial software. You guys write probably web or some applications that are in production, producing revenue. Question, what makes your software good? Or I'm actually putting kind of an answer there. How do you know your software meets the needs of the business? And that's a really important question to ask yourself, because if your software, for example, is incredibly expensive to maintain and run, and your margins are low, that will kill your business. So reducing the cost of running software is a really good thing because it allows your business to survive. So the answer to that question, the question was, oops, sorry. We're gonna have to go through this again. That's the question. Why do we care about this? What do we get? So you get different answer from different people. CEO product, or maybe head of product, will say, well, how well does the software adapt to ever-changing requirements? That's how we know it meets business needs. How quickly we can prototype, test, launch new ideas on product features. Is it reliable, scalable, and secure? This is probably the extent of how CEO or head of product thinks about fit of software into the business. Now, CFO and investors may have another angle. How much did it cost? And does it cost now to maintain and advance this application? Is it massively expensive? Is it too expensive? What is too expensive? How do we know? Well, one way of measuring this is finding the cost of running the service for a single user. I don't know, I'm curious, has anyone ever done this exercise? Wow, that's awesome. I'm really curious to hear what you guys found, but I'm guessing it's a lot. So yeah, those are the different ways we look at whether software fits business requirements. And ultimately, what we work is that the work apps, the app works correctly, that it's within the grid SLA, it supports rapid prototyping, feature development, has tests, and metrics above should not decline with application or team size as it grows. Now, what I wrote here are nice to have for every project I've been on. Has it always been like that? Not even close. You can have 2 or 3 of these, but maybe not all 5. And so I think that this talk about loose coupling is largely about how to get that very last point. Because we already know how to do the first 4. But the last one is the hard one. Okay, I'm going to skip through this. So the question therefore becomes, how do we go from a small messy app with the super high productivity that Rails gives us to a very large app without losing too much that productivity that we were enjoying? And one possible answer could be software design that's forward-looking, as it anticipates the future but does not prescribe it. And what's the best way to do it? Software that anticipates changes, then loose coupling. It is one of the simplest things to understand conceptually, but also one of the hardest to do consistently well. So what are the different ways we can actually write loosely coupled code? And I want to ask you guys, give me like 3 or 4 things. Anybody? What can we do to get our code loosely coupled? Anyone?
There's a service pattern.
Service pattern, great. Anything else? Yeah.
Like pass IDs instead of active record objects.
So data objects basically separate concern.
Individual fields as opposed to the whole thing.
Yeah, well, those are good. Those are all parts of the same thing. But I present you 3 answers that I put up. The first one is by modularizing application and using facade pattern to interface with other modules, and that's packwork approach. We're going to talk more about packwork in a little bit. Second one is by using observable pattern. It's a pattern that allows you to decouple subscribers from event producer and use events. It's very convenient. Ruby comes with observable already built in. I actually wrote a gem called Eventable that expands on this concept and allows you to create events that carry information. There's another gem called Whisper that does something similar. It's a pretty good way to separate your concerns, to subscribe to something and be notified later on. And then a third one is by using inversion of control, dependency injection. That's how you sort of end up not depending on a code class definition, you can get it passed in and avoid direct instantiation. So those are kind of different levels of loosely coupled. The last two are obviously design patterns. First one is more of a code organization. So where do we go from here? What we're going to do is next is we're going to sketch up loosely coupled modules for a typical e-commerce marketplace. Believe it or not, it's based on a real application. We'll look at several patterns that participate in loose coupling, such as facade, library, and version of control in a little bit more detail. We'll look how backward can be applied incrementally and gradually to migrate a very large app into well-defined modules. So here is the e-commerce marketplace. I want to point out the two barcodes on the side. If you get them, they will take you to Academia's job page. There's going to be more of them at the end. So what is a marketplace? Marketplace has sellers, buyers, and the marketplace itself. Think Amazon, think Etsy, whatever. So think in your head, what sort of data model would you be needing to implement if you had to build this? And what are the natural modules that you could stuff various models into that basically would become groups or modules together? Well, this is what I am basically proposing here. This is what we ended up doing, but this is not how we got there. We got there from the schema diagram, which kind of showed us that certain tables have a lot of connections, other tables don't. So here what you see is 6 different modules. The left one is called Marketplace Stores. It has store information, store details, store owners, product feeds from maybe Shopify. Now, in the middle, you see product catalog. That's where you browse. It has products, variants, inventory, and it pulls these products from the Marketplace store. So it belongs to that. We're going to skip daily sales, just coupons and stuff. But below that is user profiles and accounting. That's where we keep all user payments and transactions, as well as credit cards. Then on the right, there's a checkout module, which has cart, order, checkout, line items, and other things. At the bottom, we have seller payouts, which is basically counts for the sellers that trade. We have to transfer the money and collect tax. And of course, the seller payout communicates to the store, maybe saves the sales data or aggregates, creates reports, and so on. So this is kind of a very high level picture, but honestly, it contains majority of the components to build e-commerce marketplace, because this diagram comes from a real marketplace. So real briefly, I'm just gonna scroll you through so you can get a sense of what's inside of each of these. So user data and payment data, product catalog has product variants and so on. Marketplace stores have like stores or states, so profiles and so on. Then checkout module has orders, line items, it has cart, it has shipments, tracking, and so on. And then seller accounts obviously have various accounts with different banks, how they get money. We have a history table that we keep on, and so on. And voila, this is the whole schema of the entire thing. And when I said that we got this separation by looking at the tables, I did not lie. We actually did that because you can often look at just number of foreign keys, and you can sort of figure out by that how things relate. But yeah, that was a good exercise. So what did we learn? In most domains, it's not too difficult to learn how the data model can aggregate into modules. The order model, for example, probably needs to be in the same module as shopping cart, line item, and fulfillment, because they're all interacting together. But checkout module does not need to know necessarily what it's checking out. Maybe a polymorphic table called sellables can define what models can be checked out and how. And then product is a model from another module, but it appears in a checkout module as a data object, not as a product. That was kind of related to what you were earlier saying. You wrap active record object because you don't want to give access to another module at the database level. And this is crucial and necessary separation and has to be enforced somehow. Because the checkout module has direct access to the product model, we lose that separation. So what options do we have for loose coupling in Rails apps? We have packwork, we have Rails engines. We used them in the past. They don't have really good boundary enforcement. There's Ruby gems. Ruby gems are great for libraries, CLI tools, plugins. It's most appropriate when you depend down on a gem, and the gem doesn't need to call out up to the application layer. That way you can extract something to a very self-contained unit, run tests really fast, enjoy all that, and publish a gem, and maybe even make it open source. Maybe someone will use it. Next, we're going to look at packwork. And packwork is probably the best solution today, which is why I left it till the end, for doing what we talked about. Packwork is a gem written by Shopify, and it's written to enforce boundaries and modularize Rails application, and it's opinionated gem. It can be used to combine groups of files into packaging, define package level constant visibility, say have publicly accessible constants, help existing code bases to become more modular without abstracting development. That's really critical. And for the next 3 slides, I'm gonna have this source at the bottom. This is coming from a really amazing talk by Mark Reynolds at Rocky Mountain Ruby. I just didn't feel like I could do a better job explaining this. He did a fantastic job. I highly recommend that you write down that URL and look at it. It's a great 30-minute talk on packwork specifically, on how they moved all of their code into that, what issues they ran into. But here, what is shown is that instead of app, typical Rails app folder, we're moving towards packs folder containing sales module, reviews module, and social. And each module has an app folder that has, you know, your standard model use controllers, but also a public directory, and only public directory should contain anything that other modules talk to. And that's how that sort of relationship is enforced. So here's an example of a violation where a review class directly accesses sale active record model. And so when you run packwork check, it will tell you that you have a violation, that something is accessing it shouldn't. And that is the biggest value add of this gem. And obviously you would want to run it on CI, like once you do it. And the cool thing about it is that you can create a tiny module and move just one file there. And you could start creating these dependency sort of configurations and have this pass. And then incrementally just keep adding stuff to it and make sure this continues passing. You don't need to move everything into the project folders right away. Incremental ability to do this incrementally, I think, is what makes packwork particularly attractive. So this comes also from a talk, how to integrate packwork. Figure out what you have first. Move code into packages, declare package dependencies, open public interfaces and create data objects, document public interfaces and assign code owners. Maintain and grow. That's the hope. What about inversion of control? If you have a public interface for a module, it's sort of, sorry, this is a facade pattern, not inversion of control. Facade is basically what you would put in your public folder. You know, you can have multiple facades there, you can have one facade, probably multiple, I'm guessing, but it's essentially what you talk to instead of talking to things inside the module, you just talk to that facade. It typically wraps active record objects into some sort of hash and returns that. And dependency inversion is another kind of tool we have that basically what you can do is you can pass to checkout injected, basically you can inject data into checkout method without providing direct access to the product model, like I said earlier. So what are the key takeaways? Loosely coupled modular design does not appear out of the blue or accidentally. It is an answer to a problem of ever-growing spaghetti code base. Modular design is a necessity for larger teams with 100+ engineers working on monolithic code base. Some companies will stall at much smaller numbers. Loose coupling design encourages engineers to think in terms of components in their module and their public APIs, and use existing or negotiate new APIs with the owners of other modules. The ownership of the module is something I haven't talked about, but that's also built into backward. This means a good chance of doing it right without adding any new technical debt. Backward perhaps offers the most flexible, incremental, well-traveled path to modularity for any Ruby code base. And it's the only tool currently used in production by Shopify and many others. In the end, we can hopefully all enjoy loosely coupled code bases and speed up their velocity and stick that. That's all we have time for today, for me. Any questions?
Are you guys using Packwork at Academia?
No, we're not yet. We want to.
What are your thoughts on Hanami, which is similar in design with its slices as to what Packwork does?
I haven't looked at Hanami as a Packwork replacement. Does it have a gem that does that as part of it? Because Hanami relies on dry RP.
I think it's like built into the Hanami thing. This is how you separate it for everything.
Interesting. That might be another option, but honestly, if you have a Rails application that's been in development for 10 years, Hanami may not be the answer. What else?
Konstantin, how do you think about hello. How do you think about the value of splitting code out of a Rails monolith versus putting it into a Packwork module?
That's a great question. I think that having been large companies, Coinbase, several others, most of these guys moved to a concept of a monorepo, which is where they put everything in a single repo and have a build system build it all. So I don't think that we should be going in the splitting repo direction. I think we should be splitting things within the repo, but effectively and with enforcement. And I think that'll allow us to grow monolith to much larger size. Any more questions? Our last one. All right, thank you very much.
Thanks, Konstantin. That was great. Chris is getting set up. You're on time.
It's my time.
It's morning. Wake up. Chris, that's the company that your talk is based on have 100 engineers.
No, we don't even have 100 employees.
So what do they do? So you don't have 100 employees. Nice. That's refreshing. So we have nice diversity.
Repos, which are
Perfect. Like Chris.
together
Technically.
only.
Okay, yeah, hello, everybody. Thank you for giving me the opportunity here to share this story. It's one that I find really interesting and pretty fun to learn about. So yeah, without further ado, this is how to translate your Rails app into over 20 languages, and why you should. So first off, who am I? My name is Chris Fung, like you're gonna introduce me as. You can find me on Blue Sky at Ergonaut, also on Mastodon at ruby.social. I've been doing Ruby and Rails for over 10 years at this point. And currently I am a staff software engineer at Binti. And what is Binti? Just to give you a quick rundown, we're a mission-driven SaaS company that believes every child deserves a loving family. Our software is used by foster agencies to help them optimize and save time and reduce cycle time and all that for their social workers who are out in the field working with children who need to be placed with foster homes and making sure that they're having like a safe and loving and supportive environment in those homes. We're in over 500 agencies across the nation, 34 states plus DC, and they have over 150,000 children in care. So this talk is about localization and how we localized our UI into over 20 languages. But what is localization first off, and why should you care about it? So here's some definitions here. The first one, L10N or localization, you'll often see these words abbreviated with numbers, means to adapt content from one locale into another. So the classic example is what you might call translation, which is when we take text from the language, like hello in English here, and we turn it into Portuguese. So it says hola instead. But localization also applies to other forms of data. So like dates are a good example. We write dates in one way here in the US, but in other parts of the world, like in the UK, they write them a different way. So that's also a form of localization. And when I say locale, so a locale is an identifier, basically, that just represents a language, optionally with a region and a script attached. So I have some examples here. EN just means English. PT-PR stands for Portuguese as it's spoken in Brazil. And then the last one there is Chinese written in Han traditional characters as spoken in Hong Kong. So these can get really specific, really down to like minute details about the language and who speaks it and where they are. And then finally, internationalizations, this is the last one here. It means to adapt software so it can easily support many different languages, scripts, regions, and cultures. And so the idea is internationalization is what we as devs do to a product. You make a product internationalized, and that allows you to localize it multiple times from your source language into whatever targets you want. So that's all well and good, right? But why should you care? Don't most people speak English, right? Like, isn't that just enough? Well, I mean, I wouldn't be here if that was true, right? So just show of hands, who speaks English as a second language here? Okay, cool. How about who knows someone who speaks English as a second language? I think that should be everyone. Yeah, right. So worldwide, there's 1.5 billion English speakers, but there are 8 billion people in the world. So that's, when you think about it, that's like 6.5 billion people for whom English is not their first language. And even in the US, like if you look at the US Census data, there are 21.7% of people who speak a language other than English at home. And 8.2% of US residents say they speak English less than very well. And so that's all to say that like English is not enough for your application if you really want to grow. Like you might default to English and it's a good place to start, but even in the US, English is not enough if you want to reach the most people, especially people who may have been underserved or excluded from technology due to their language. Okay, so let's say you have a Rails app and you decided you want to localize. That's great, yeah. What do you need to do? So here's your roadmap. You have 5 steps. First, you have to externalize all your text. Then you'll choose your target locales. Then translate, commit, and push. And then just reap the profits, I guess. So step 1 is to externalize your strings. And there's a lot more to externalizing than what I can cover here. But the basic idea is you have to look throughout your app to find hard-coded text anywhere that it might appear to a user. And so this is like obvious stuff like in your view templates, for example. Like here we have an H1 tag and it says edit user. But you can also look in controllers, like flash messages are a very common place that text, user-facing text gets generated inside of controller. But you also have stuff like in your models where you might have a validation message or an error message that gets generated, and that also gets shown to a user. And we need to extract the text because as it is, right, like there's no way this text could change. Like if I want to show the app in Portuguese, or if I want to show it in Chinese, like this text is in English, it's in the source code, it can't change. So once you've identified some hard-coded text, the next step you have to actually extract it. And by default, Rails uses YAML files to store strings, and it'll even generate an en.yaml file for you when you start a new app. So you just open that up, and then you take your strings that you identified in the previous step and give each one of them a unique key. So here, like we've given our edit user message, the user's edit title key, and we gave that flash message flash save. And so the idea here is that the keys will remain the same when we translate this file into other languages, but then the messages will all get translated into whatever target locale. So finally, once you've got those extracted, then we can go back to the original place and just replace the text with iatn.t or one of its variants. There's a couple different ways to call iatn, depending on where you are. So, and the benefit here is like now when this code runs, iatn will look up the key. It'll go to the locale file matching the current locale, take out the right message, and show it to the user. So now this makes the app internationalized because we can change the locale at runtime, and all the text will change and it'll all get updated. So step 2 is to choose your target locales. And this will vary depending on the particulars of your situation. But a good place to start is with these 3 questions here. So what are your company's goals? What are your most important markets? And who is your company trying to reach? So if you're a global product, you can start by looking at what regions you're targeting and find out what is the most spoken languages in those regions. So a good resource for this is Ethnologue, which I just have up here. This is just a screenshot of their homepage. They have stats on language use across the entire world for every country, every region that you might want. You can also just look this up on Wikipedia. That's also relatively easy to do. And if your main market is in the US, though, like it is for us at Binti, you can look at the US Census data instead. And the US Census website is actually really great. It lets you can segment the data based on state or just nationwide, and they let you see all these different combinations of the data to like derive different insights. Specifically, the one I have highlighted here shows the number of respondents who say they speak a given language, and then breaks it out based on whether they say they speak English very well or they speak English less than very well. And so this helps like us to identify who might be best served by a localized app experience, because we can see like, oh, those 258,000 people who speak French and they say they speak English less than very well, they'd be really helped by having a French version of an app. So once you know which languages you want to target, so you have to convert those languages into locale codes. These are those identifiers I mentioned earlier. There's a lot of ways to do this again. Like I like using this tool that I have linked up here. You can also, again, just like Google the language on Wikipedia. It usually has the code there in the sidebar. And then, so once you found the codes, there's also a couple of different formats for the codes. If you're not sure which format you want to use, I just recommend you stick to the language tag format, which uses dashes there. But there's also the GNU format, which uses an underscore. There's no real like benefit to either one. The main thing is just like, if you have another tool in your stack that uses or is locale aware, it's good to keep your codes and formats all consistent, just so you don't have to like convert back and forth. Okay, so step 3 is translate. And this is the fun part. And again, depending on how your company, like how big your company is, your company size, how you approach this might differ. So if you're a little bit bigger, you might contract with a language services provider or LSP, which can help you obtain professional translations from like professional translators. And this might be important to you if precision is really important in your company, or if you're in a highly regulated industry with a lot of jargon, or even if you're just like, you just have customers and they're like really critical of what your app looks like. Having professional translations might be important. If you're a little smaller, you might consider AI-powered machine translation instead. It's relatively easy to get started, and you can do a DIY with this IATN tasks gem, which gives you access to OpenAI, Google, DeepL, a bunch of different providers. And if you want something a little bit more off the shelf, you can use a localization platform like one of these I've listed up here. But for now, let's say we want to go the DIY route. Because yeah, it's pretty easy and lets you get going fast. So let's set up IATN tasks. It's just a gem. You can add it to your gem file. And then you have to choose a translation provider. So for example, like Google Translate, for example. You get an API key for your provider, and then IATN tasks, it uses environment variables to configure. So it wants the Google Translate API key and this Google Translate API key environment variable. So let's put it there. And then finally, you can run this translate missing command that I have up here on screen. This will basically take all of your English text and then translate it into all of the different locales using whatever provider you selected. And in the end, you'll end up with one YAML file for each of your target locales. So now it's time, once you got all those files generated, now you can commit and push. But watch out, because the locale files can be pretty large and you might run into some problems. For example, GitHub could reject your push if it's too big. This is actually a thing that happened to me when I was doing this at Binti. I had to split up my PR into one commit for every language because the commits were just too big. The extra files could add bloat, which may make like cloning your repo slower, or make your repo's source code take up more disk space on whatever like provider or wherever you deploy to. All of those extra string objects, they could lead to increased memory usage at runtime. And they could also lead to increased asset size if you do something like bundle your translations into your JavaScript for your front end. These are all just like potential problems that you want to look out for. So you can have like, you should have monitoring or some sort of alerts to like alert you if something's going wrong. But assuming nothing is, congrats. That's all you need to do. Your app is translated. But wait, you're not really done, because that's just the beginning. There's a whole lot more to internationalization than just translating text. And to give you a taste, here's like 3 things that we at Binti were looking at next after doing this initial translation push. So localized formatting is the top one. This is, like I said before, dates, numbers, even calendars, like how a calendar is laid out and what the months are called and how you name the days. Those all vary based on region and based on language. Plural rules, so stuff like if you have a phrase like "n applications were updated," the phrase changes based on how many, what n is, if it's 1 or 2 or whatever. English, we just have single and plural, but other languages may have more or less categories. And the last one here is continuous localization, which basically just means automate everything I've just been talking about, which is really like a lot harder than it actually sounds. Okay, so this talk is based on Binti's experience translating our app into 21 different languages, hence the title. And I just wanted to wrap this up by sharing a little story about our journey at Binti and what we learned. So part of Binti's mission is helping foster agencies, who are our customers, reach more families so they can find more caregivers for children in need. And many of these potential caregivers are older, less familiar with technology, less comfortable with English. And so even though we only really have US customers, localization and internationalization were still a very important thing for us. So when we started, we had English and then manually translated Spanish, just basically based by Spanish speakers who were employees. We used the US Census data to identify 19 new languages. The list is there on the screen. And this covered about 65% of the less than very well English speakers. And then we translated using ITN tasks and the Google Translate API. And along the way, we learned a lot about multilingual text and UIs. So the first learning that I wanted to share is just about multilingual fonts. So you probably use a custom font in your application, but what you might not know is that not all fonts support non-Latin scripts like Cyrillic or Greek. And when a browser encounters text that is not supported by the current font, it'll fall back to the system font. And so in Binti's case, we noticed that the fallback was sometimes inconsistent. Like it would be a serif font when our main font was a sans serif font. And so, so it ended up being because we weren't consistently specifying at the base of our font stack, serif or sans serif. And so that's the learning here, like always be consistent and have serif or sans serif at the base of your font stack so that the browser will be able to choose a visually consistent font to match like the rest of your app. And by the way, if you're using Tailwind, which many people probably are, maybe, you're probably already covered because the inter font that Tailwind uses by default includes Cyrillic and Greek, which is like a great start. The second is bidirectional text, also called right to left. Some scripts like Arabic or Hebrew, they flow right to left across the screen. And you might think that that's just about the text, but it's really about like way more than just the text. And there's a lot of like unexpected impacts on your app's UI and the UX of your app. So some interesting stuff here is like point 3 highlighted in that screenshot, the button order, like the primary button should be on the right of a list of buttons first, whereas in like English, it might be on the left. Checkboxes and icons usually appear on the right versus like on the left. And what was most surprising to me, progress bars, they fill from the right to the left. So like 0 is on the right versus, and 100 is on the left, which is like backwards. And so the learning here is that RTL is about a way more than just text. Like you can translate to the text, but like it impacts the entire UI and UX of your application. And so the last topic I have here is about locale names. And this is like super surprising to me when we discovered it. So like it might seem simple, right? Like you should just be able to write the locale names in English and translate them into the other languages and that should be fine. Like, right? You would think that'd be true. But actually different languages and different regions have different formats for how they name other languages. So like in English, we might say Canadian French, but in German, actually it's, I'm not gonna try to pronounce German, but French and then Canada in parentheses, and it's supposed to be in parentheses. And so the learning here is like, don't machine translate these. We ended up leveraging data from the Unicode Common Locale Data Repository, which is a standardized set of data files that have all sorts of data about languages across the world. And we used that data to help build this language selector that you see on screen here. Yeah, okay, so that's all I have. Thank you everybody for listening, and yeah, good luck. Do I have time for questions? Yeah. Yeah.
Wherever you want to start.
I think he had his hand up first.
Great talk, Chris. I wanted to ask, how do you ensure the accuracy of Google Translate? Because sometimes it's not always accurate.
Yeah, great question. So right now the answer is we don't. But there is a practice called linguistic QA that you should, like, as you grow along your journey, that's something you can look at. Usually what you end up doing is you have a human who is a native speaker, like edit the machine's output so they can see like, oh, is it saying this phrase wrong, or like, oh, this is a weird way to structure this, let's rewrite it. So that's normally how you would approach that, but we're not there yet.
I actually had the same question, so I'll just add that I remember hearing Bill Sullivan, who was one of the global VPs at IBM, talk about this at Localization World. He said that it's called Sullivan's Law. He said that any person's willingness to use machine translation is inversely proportional to their knowledge of a second language. That was really funny. I guess, but you already answered the question, so I'll hand off the microphone now.
Yeah, I think like machine translation has gotten a lot better in recent years, especially with the rise of AI, but yeah, they're not perfect yet, definitely.
I have a related one actually I can shout out. So you mentioned multiple different providers. Did you try Google Translate against an AI solution? And if so, how did you find the quality difference there?
Yeah, so we did try Google Translate versus OpenAI, like directly and through Azure. I think that was the only one we tried. Just the thing about it was like, it was mostly a cost thing, like it was more expensive to use OpenAI, so we ended up using Google Translate, and Google Translate's translations are actually like pretty good, and you can, if you use the one from Google Cloud, I think they actually incorporate some AI functionality into the Google Translate API there.
I have a kind of funny story. Years ago, we at Martians were doing like a project for eBay, localization project, which meant we had to translate eBay's item names. And so imagine there's a catalog, which is huge. And of course, like most of the items, yeah, we use machine translation for that because it's like millions of them, or like whatever. And but my favorite category was music. So you go to music category and it tries to translate all the band names. That's crazy.
After the migration, how have you prevented future infractions from entering the code base? I know you mentioned automation and CI. Just curious how you're thinking about that.
Yeah, that's a great point. So like definitely as you like, once you translate, if like your devs are gonna put more text into the app, right? So you have to, that's why continuous localization is an important thing, and we're working towards that. Right now, basically like we just have to rely on somebody to like go and run the translation again to like get everything back up to speed, but like that's obviously not scalable, and we want to like make that faster. So like continuous translation means just automating everything, detecting changes, and running the translation continuously.
I just shout out. I got it. So there's like the technical piece of the translation, but I'm curious, somebody emails you in a different language, maybe nobody on the team knows it. How do you deal with that? Is there a tool? Does somebody on the team know the language? Like, how do you decide kind of the back office stuff behind the application?
Yeah, so the question is like, yeah, I covered your UI translation, but yeah, how do you do everything else? Like inbound support in a different language, or other kinds of like receiving other communication in other languages. So that's where a good thing like leveraging a localization platform, like I mentioned, Crowdin and Phrase as two ones that on my slides. They have different integrations with like Zendesk or whatever intercom, whatever like help desk tool you want to use, and they can provide like tools for your support text to like automatically translate messages back and forth. So that's one thing you could do. Yeah, I think like, again, like we're not there yet. We do have like, we want to get there because like our support needs to be able to communicate with people. And if we're making the app available in Bengali, someone types in Bengali to our support text, they need to be able to understand. But like that's something we're not there yet.
I just had a question about maybe like kind of more like the product road mapping process of this, because I'm working in an app that's like 20 years old. And we do have an international like user base, but we've kind of been like scrabbling that together. But we're doing an overhaul into Flex with our UI. And so we're using this as a chance to add in those translation keys. But it's kind of like well, then what is this process going to look like when we actually go to do it? So I that's a long-winded way to say like, did you have a team that was like fully focused on this while like other teams were shipping out? Was this like all hands on deck kind of thing? You could speak to that process.
Yeah, good question. So this whole journey that I spoke about was handled by my team, basically. So it was me and 2 other devs. We were basically taking this and a couple other related AI translation features, like all at once is like our work for basically like the summer. I think it was like that we worked on it for about a quarter. And so like, yeah, we were entirely focused on this. Everyone else at our company, they were all doing their own features. So it was basically just us. And then when we shipped it out, it's so far been working good.
Go back behind them and sweep up.
Yeah, essentially, yeah.
Hey, everybody, my name is Todd. I'm with Rocketship Solutions. It's a small consulting firm. 2 people, we do Ruby on Rails consulting. Tonight, I'd like to tell you about the first gem that I recently published. It's called Filterameter, and it enables declarative filter parameters that make it easy to turn search query parameters into Rails active record. And so if I could share a quick couple things about it. The first one would be that it makes your controllers very easy to read. You open it up, and if there's say a filter on size, it literally says filter size. The second thing I'll tell you about it is that it makes writing controllers faster, simpler, and so the development process is fast as well. It really leverages active record. At the end, it outputs active record, and you can start with an active record as well. So nothing new, it's very simple, fits in well. And the last thing I'll tell you about it is that it plays well with others. Sometimes I get worried when I bring a gem in, like what is it doing? What are the hooks? Has it monkey patched? This doesn't do anything by default. You have to pull it into a controller, mix it in. If you love it, you can mix it into application controller. And then even then you have to invoke it in order for it to do anything. So it's really easy to bring in and try it out. So I'd love for you to check it out. The name is Filterameter. Filter parameters is where the name came from. If it looks like something that might be helpful, if you put a star on the repo, that helps spread the word. Thank you very much.
Okay, so my Rails skills are out of date, but I realize that my product management skills are still solid as a rock. So if any of you are looking for a product manager, especially if you've got a Rails team, I actually can write specifications. I can write requirements in Cucumber. So if you're looking for a good product manager who works with a Rails team, I'm your guy.
Did you say your name?
I am Ken.
Ken, awesome.
I did not.
Just want to make sure your name was out there. You know?
Very good.
I'm Cameron Dutro. I work for GitHub. The only thing I wanted to bring up today is this really cool website that I heard about at RubyConf in Chicago last week. Who knows who Marco Roth is? Yeah, he was actually at our first meetup in SF. I think he flew in from Germany. He has put together, I'm gonna pull my phone out. What's that?
Switzerland.
Oh, Switzerland. Oh, I'm so sorry. Let me just pull up the actual website here so I get the name right. Yes, okay, so he is a big conference attender, meetup attender, and he's put together a website called rubyvideo.dev. If you haven't heard of it, it's super cool. He's like indexed pretty much every talk from every conference you've ever heard of, going back to like 2006, I think. On this website, you can go find your profile if you've been a speaker, claim it. You can see all the videos, you can search, sort, it's good descriptions of the videos, sometimes transcripts. It's really, really cool. So take a look at rubyvideo.dev.
To follow up on that, rubyvideo.dev is about to be linked from Ruby's official website. There's a pull request open that's going to be merged very soon.
Hello, I'm Dave. I'm working with American Legion Post 599 here in San Francisco, which meets in the War Memorial Building, which is a theater. And this better, right on. We have a monthly Code and Connect for veterans and friends of veterans that meets roughly the second Wednesday of every month. And anyone who is a veteran, if you know veteran, if you would like to come and help veterans, it's open to the public as well. The venue is fantastic and it's very close to BART. Hit me up afterwards. I may do this again at future meetups, just to drum up some interest.
Hey, my name's Brian. Based on the last talk, I just want to give props to the US Census Bureau. They have some amazing data. There's a gem I maintain called US Geo, which takes the geographic data from the US Census Bureau and normalizes it into a relational data structure to make it far more usable. It includes things like population density, housing density. We use it for things like have a zip code. I can tell you the county, the state, the metropolitan area, the urbanized area. Is it urban? Is it rural? So if you ever need to use any of that data, it's all based on active record, but there's CSV files available to download. You can put them in Excel.
And the last one of today, I think.
The 5?
No.
6.
Yours.
Six.
Yeah, any of them.
Okay, since this is open mic, so just gonna tell you that a daily basis documentation, like listen to your heart and also to your lungs. I've been working a lot the last quarter, trying to improve our quality of our application in general. And it's been interesting to learn to, show to my coworkers how to read logs and what it meant of everything, how to pipe them to other places to Grafana, or create that on OpenTelemetry and say this is it. Because you cannot just try to figure out how to improve something by saying that it's better, it's not better. So this introduces you to some kind of a new world about the statistics, where you can tell why this changes. Just not because it's fast, you say, just I take it. Or maybe there is another thing that you maybe are affecting other places, but you need to know what you are doing. So everything starts from, listen to it.
Hi, my name is Atkin, and I'm working on an open source project called Macchiato. It's at macchiato.dev. And the first project is called Ristretto. And it's undergoing a redesign, but basically it's like a code notebook that is like for editing Markdown. And part of the idea was that you could run code that you're playing with and use it with real data. And so it had a security sandbox. And the reason I'm redoing it is because the security sandbox didn't actually prevent exfiltration. If you go to the WebAxSec CSP content security policy page or GitHub repo and look at the issues, there's some concerns about actually preventing exfiltration. The browser's security model with content security policy is really good at keeping one tab separate from the other. But you can't really run untrusted code on it because it could set up connections because the DOM API surface area is so huge. So what I'm doing now is I'm basically allow listing the code that runs directly in the browser and interacts with a DOM. And so I'm building code modules that, for instance, won't link you to a site. So if you use the spreadsheet module, you'll have to tell it which URLs you want to be able to clickable when you link them. So if this sounds interesting to you, talk to me or go to macchiato.dev and there'll be a link to the Ristretto code base there. And you can check out the code. And I'm Ben Atkin on GitHub, and that's where my email address is because GitHub has the slightly harder to scrape email address. That's like the JavaScript generated email address, so.
Nice. I don't, this is my favorite part of this. So for if you didn't have a chance to speak today, you have the next meetup. Remember, there's always the next one. So Brad is starting up, and Brad is the person who builds so many things. Brad, do you know, I gave a bunch of talks this year, and I used Brad's first, maybe not the first, but one of the early products built by Brad Gessler, Poll Everywhere. I used it during my presentations. It was pretty funny. You can it's gonna use in WebSockets and stuff for real-time votes. Yeah, but today, Brad is gonna share something about
I'm gonna talk about Cypress.
Cypress. Yeah.
I figured I'd tail on the open mic and say, if you're Blue Sky curious, or you're on Blue Sky, on the right, if you scan that QR code, I've been throwing as many people who hack on Ruby as I can on there, including people who are presenting tonight. And then on the left, if you want to see like chill Twitter vibes from say 10 or 15 years ago when the fail whale was a thing, this is what it looks like. We have some, I don't know, some Western themed bedspreads going on there, somebody's backyard. There's a retro chat GPT. Pretty chill vibes. I think like what's missing from this is just like intense, crazy stuff. So if you're kind of in the mood for just kind of more of a chill doom scrolling that feels less doomy, check out Blue Sky. And also find me on there and tell me that you want to be on this list if you're on Blue Sky and you hack on this. And last thing, you can actually set up your domain name as your username. So I'm at bradgessler.com on there, and you should get on there, hook your domain up to it, and you can have any domain you want as long as it's available. All right, so with that, I'm going to talk about an open source project I've been working on for quite some time now. I didn't realize that until I put this together, called Sitepress. Just a quick show of hands, how many of you are using Sitepress? All right, that's fine. I was asking what should I talk about for this presentation, and I didn't get any responses, so that's good. I'm glad nobody raised their hand, because I'm gonna kind of run through an intro crash course. But I'm gonna skip the basics, because that's all on the website, and I'm gonna run into like, okay, here's what kind of peak usage looks like with Sitepress, and some of the interesting things you can do with it. But first, you need to understand, what are my motivations behind Sitepress? Why did I build it? Quick show of hands, who's heard of Middleman? All right, good. I got a decent starting place. So you may be familiar with this. It's a static site generator. You can take a bunch of markdown files, HAML files, and whatever, and throw it in a folder, type compile, and then it just generates an HTML site. You can upload it to S3 or what have you. So I started with this in 2015, and I was pretty happy with Middleman until I tried to embed it in a Rails application. And then I just started running into dependency hell. So this was me actually today. Don't let the amber CRT screen throw you off. So I'm just looking at these dependencies, and if you've worked with Rails for a while, you'll know that these dependencies cause problems. So I was defeated whenever I tried to embed Middleman into Rails. And I thought, you know what? Jekyll will just embed in Rails. And guess what? It also had the same dependency hell. So a lot of these things, if you, again, have ever worked with Rails, it just doesn't work. Maybe it works with Rails 5, but as soon as you upgrade to Rails 6, too bad, your IA18N framework isn't compatible. So it breaks the whole thing, and it's just not pleasant. So I set off to build Middleman and Rails. And my daughter is now 8, so she's a lot bigger than she was in that picture. But it is actually Sitepress code to the right. You may recognize tilt is in there. It is no longer in there. It's just, I'll get to that actually. Kind of a fun journey. So here's proof in the commit log. February of 2016 was the initial commit. And Sitepress is now over 8 years old, which means that I think Sitepress is finally good. It's almost good enough. I think in 2 more years, it'll finally be ready. All right, so on the intro slide, you may have noticed that Sitepress, you can build ambitious content sites in Rails. That's kind of what I tell people to not explode their brains. It can do a lot of things. It can generate static websites. You can embed it in Rails. You can do both, or you can have your cake and eat it too. And apparently when cake eats itself, it has it too, it enjoys a nice glass of wine with it. All right, so if you start using Sitepress, this is what it would be like if you use it as a static site generator. You install the gem, you create a site, you fire up the server, and then you compile it, you get a bunch of HTML files, just like Middleman and Jekyll. But it changes. You can actually embed it in Rails. So in a Rails application, if you run bundle add Sitepress Rails, and then you install it, you will get an app content folder. And I'm actually gonna do some live coding demos to kind of give you a tour of what that looks like. The other thing that you can do, and I've done a lot more of this lately, is you can just run Sitepress as a standalone server, because I'm gonna let you in on a little secret here. Sitepress is just a teeny tiny Rails server. So if you look at the screen here on line 11, you can see that Sitepress server just inherits the Rails application server. I did this entirely by accident, and I want to say about 3 years ago this happened when I realized that, oh wait, I don't have to maintain all this web stuff. I can just let Rails do that. I can kind of ride on their shoulders, and then I can just delete a ton of code. And it's awesome because Rails 8 comes out and I get all the performance benefits and all sorts of stuff. Which, speaking of performance, I built Sitepress to get a content website working in pull everywhere. I was at Fly for about 2 years, and one of the first projects I did there is they had a middleman instance, and it was something like 1,000 pages of documentation that took about 10 minutes to build. So I said, you know what, just for fun, I'm gonna try moving all that middleman stuff over into Sitepress. And it brought the build down to 30 seconds. So thousands of pages compiled in about 30 seconds. And I didn't even do anything special with the compiler. It just page after page, serial, there's no concurrency. I'm not hitting multiple CPUs. I was able to crank out thousands of pages in 30 seconds. So I figure if I ever need to compile tens of thousands or hundreds of thousands of pages, maybe I'll look into running that across multiple CPUs. All right, so a lot of websites has used it, but the one that I want to show you today is mine. I gave a presentation on this, I think, 2 meetups ago, but lately for the past month, I've been working on documentation, because if you're building a tool for developers, developers like really good documentation. And so, of course, I reached for Sitepress to build that. And now I'm going to jump into a demo, and we'll see if I can do this one-handed while holding a microphone. All right. You want someone to hold the mic? Yeah, I'll see if it works, but thanks for the offer. I might take you up on that.
I was like, I would do it.
No, that's what I heard. All right.
I think we all heard that.
Yeah. So hopefully I have the server running here. Yeah, all right. And I'm going to zoom in a bit. All right, so these are the documents on TerminalWire. I call them manuals and licensing. I'm kind of playing around with going old school on this. And you know what? Instead of docs, let's call it manuals. Instead of pricing, let's call it licensing. So I thought it'd be kind of cool. Manuals are these like books, right? And books have chapters in them. So let's take a look at the Ruby on Rails documentation. You can see we have chapters, sessions. We have all these chapters over here. There's a cover. If I actually click on the cover, kind of have this like landing page type thing here. And we can see the content, table of contents, so on and so forth. So what does this actually look like in Sitepress? And I'm going to start first with the content. But one thing I like about Sitepress is it's not a mystery of where is the content. I can see the URL here. It says docs Rails, so I know that I'm going to have a file in my Rails application. I should see if I can crank the resolution up here so you can see this a little bit better. No, it's too late. I'm just going to kind of word it out. All right, so we have a thanks. All right, so we have a folder called app content, and content is kind of where everything lives here. We have pages. So if I go into docs and Rails, we can see here, we have the markdown file, the title, the subtitle, all that stuff. So let's say that nobody knows what Ruby on Rails is, but they know what Rails is. So we change that, hit refresh, and you can see how everything updates. So that's starting with the content. Now we have the content, which is a bunch of files.
And I have these things called page models. So this kind of gets into some of the more advanced use cases with Sitepress. So we have a manual page, and this is kind of like the cover, right? So think of this as just a manual. A manual has a title. We have these CSS classes, and those are pulled in. You can almost think of this as like an active record model for content. And the thing that I care about the most is that a manual has many chapters. And so we're creating these instances of chapter pages. And this is what a chapter page looks like. So we have a chapter number. We have the manual, which is the parent page. And then, of course, we have a title and a subtitle. And then if we actually look at a view, so similar to Rails, we have a model, it has a view. So let's open a manual view. This might look a little crazy because it's all done in Flex. I don't use any ERB in my projects anymore, or Haml or any of that, it's just all Flex. But you'll see here that I grab the manual, create an instance of the manual, and then I can call that from here, and I can say, hey, let's pull the CSS class, here's the manual title, and then here's the first chapter, and then we want to render the cover, and then this is the table of contents. So we see here, we have that, and then we can say, hey, give me all the chapters. And you can loop through that, just like you do an active record model. All right, so I had this checklist here to make sure that I've covered everything. And oh, the last one, I knew I'd forget. Headless CMS by a terminal wire CLI. So you've probably heard of like headless content management systems, where they'll expose this stuff as like a JSON API. I kind of compare that to service-oriented architecture. Like, why would you want to have an API between yourself and the content in HTTP? Just call a model in memory. So if I open up the manual application terminal, you can see here I have this model, and I say, hey, give me all the manuals. And let's run that command. Yeah. All right, so these are all the manuals. So, gotta make it bigger. And then just for fun, let's read the Rails manual. And we'll see all that markdown content be emitted into the CLI. And all that is streamed over terminal wire. So there's no APIs involved here. It just streams the standard IO from this terminal. And you can see I run it through this tool that converts the markdown from my manual into something that the terminal can understand. And then I emit it to the screen, and I stream it over WebSockets to the client. Thanks. All right. So that's it for the demo. I'm going to hit on a few future Sitepress things that I've just kind of thought about doing this and working with this for the past 8 years. If anybody knows Joel Draper, he works on Flex. He's infected my mind with Flex, and now I see the entire world as Flex. So Site Flex is something that I think would be fun. If you've worked with Markdown, you've probably thought, oh, it'd be nice if we could have like multiple blocks and not just this one block that we call body. I think this could accomplish that. The syntax highlighting looks pretty nice here, and if you're using here docs and the right like Z, you'll have syntax highlighting if you're embedding Markdown inside of your Ruby. So this is something I'm playing with. I'm not quite sure how these pieces fit together yet, but I have some ideas on how to get this put together. The other thing I want to clean up are the page models. It was a lot of code that you saw when I was showing the page models of the manual and the chapters. I think that could be cleaned up with active models. So you could say a blog has many posts, a manual has many chapters. So something like that looks a lot like active model, but working with content. This one's easy. I have a PR open for it, but if you look deep down, the way the pages render are kind of crazy. So I can kind of self-contain that in a page, and a page could tell Rails, hey, here's how you should render me. I marked down, I'm something else. There's some helpers that I can improve in the page URL. And that's kind of it for the future things that I would do for Sitepress. I did miss another thing that I worked on. Maybe it'll be a different time because we were running short on time. But I do maintain another gem called markdown-rails. And if you have a .html.md file in your Rails application, it'll render that. And you can actually edit that template handler during your development environment. Just refresh the page and it'll update. You don't have to restart the server or do anything like that. And you can even run like 5 different flavors of Markdown in one Rails application if you want. Maybe another day. But if you scan that QR code, you can get the slides, and then there's all that fun stuff on the side if you want the links. It's all of that code. Any questions?
I have questions.
Yeah.
Did you ever get to the bottom of why middleman was so slow at Fly?
I didn't dig too deep. When I dug into it, I think what I was doing is I was rendering the HTML as a giant string. And then kind of for each middleware that it has, I would just like try to parse the entire page as one string and then make changes. So like if there was like an image asset helper, it would have to like essentially go through HTML and find whatever it is that it's looking for. Whereas Rails, it's just calling it like ERB, or it's just calling it like one way through its rendering engine and spitting it out. That's the kind of the best I came to. I did look at the like why was the concurrency thing so slow, and I just couldn't really work that out. I'm also just not that great whenever it comes with like concurrency and Ruby. Yeah.
So would it be fair to say that you cut out the middleman?
Yes. Just straight to the source. Yes.
Wow.
I like a good pun. Who can top that pun?
I'm sorry, I don't actually have a question. I just was gonna say that.
No, that was good.
I like to say that it's like if you take WordPress and SiteGround and find the two.
Yeah. Yeah, I think Sitepress is an Adobe trademark thing. I haven't heard from. Also the if anybody goes to SiteGlass, coincidence, right?
Yeah, of course.
Well, I actually do have a question though.
Right.
What is I looked at the code already, and there's a Sitepress Rails gem and a Sitepress core gem. Does that mean that it can run without Rails? Or is that like, or is the core like the CLI or something? Like how's it structured?
Yeah, good eye. So yeah, technically you could run core without Rails. That's really kind of a relic from before when I was looking at Middleman and Jekyll, and it's like, oh, they run without Rails and all these web frameworks. But I did realize like, oh, actually it's kind of nice just to, I don't have to deal with all the web stuff. Like I just let Rails deal with that. But that said, like, Sitepress core does deal with traversal. So if you say like current page, children, parent, it will deal with all that stuff. So I think in theory you could take core and point at a directory and traverse it using just Sitepress core without needing Sitepress Rails.
So where you might wind up at, would it be possible that you might wind up with depending on some of the Rails gems, but not depending on the entire Rails?
Yeah, so if I skip back to this slide, you can see on lines 1, 2, and 3, those are my requirements. 2, the sprockets rail tie, like you don't really even need that. It should be prop shaft. But really, I'm just using, the only dependencies I'm using from Rails is action controller rail tie, and of course, like that ties in a bunch of stuff like active support and like lots of other stuff. So it's pretty big, but I found that if you're working with a lot of Rails applications and you just want to view everything in the world as Flex and Rails, as I do, like I have a hammer, so everything's a nail. It works for me. But yeah, it won't work for other people who are just working outside of Rails. You could use Sitepress core, but this is really kind of built for people who are just familiar with Rails, productive in Rails, and you know, want to use that. But you can run it standalone and just not even know that Rails is running underneath it. But it also does work with like a lot of Rails plugins, so that's kind of another benefit. You can just technically throw a Rails plugin in there and it'll kind of work. It takes some effort, but this has access to the whole Rails plugin ecosystem. Oh, yeah.
8 years later, how does this compare to Bridgetown?
I haven't done a side-by-side with Bridgetown, but I have had a few people tell me it's faster. That's it. Yeah, I know Jeremy, I can't remember his last name, has worked with Bridgetown, and they're doing some interesting things to it, but I don't know how or why it was faster. It could be the person that was using it just wasn't holding it right. I don't know, but that's kind of all I've heard about it. I talked to Jeremy a bit a while back. I forget what we were talking about, maybe like using Sitepress core to handle the page traversal and stuff and plugins, but I haven't done like really a side-by-side comparison. The only like, I've only been deep on Middleman and Sitepress. And I know Middleman just has way too much going on. Any other questions? All right.
HDMI or?
All right, so thanks, Brad. Great presentation. Two of them or three of them. Okay. Yeah. Jeremy's setting up. I gotta make a short intro here. Jeremy Evans, for me, is the legendary Rubyist. And at Evil Martians, when we recommend books for kind of some sort of advanced Rubyists, we recommend Polished Ruby Programming by Jeremy Evans. So this is a huge honor to have you today with all of us to share. And I think it's going to be super interesting for many who've never maybe used, I don't know, Roda. I think more people probably used SQL. But I think all of us want to learn from you, from Jeremy, regardless if we could use directly Jeremy's projects or not. It's just that it's an amazing example of building high quality software. Thank you.
Thank you very much. I'm super happy to be here to talk to you all. I'm honored that you asked me to come present, talk about Roda. So Roda is a web toolkit that I launched in 2014. So I'm going to go over in this presentation, I'm going to go over my background a little bit. I'll walk through a brief example using Roda, discuss Roda's goals and how it achieves them, examine the progress made in the last 10 years since Roda's launch, and then I'll show how some open source software uses Roda. My name is Jeremy Evans. This is my first time attending the San Francisco Bay Area Ruby Meetup. I'm hoping to be able to make it down here for future meetups. I live in Sacramento, so I'm not too far away. I've been using Ruby for almost 20 years. I think I was originally introduced to Ruby in December 2004, and it quickly became my favorite programming language. I maintain Roda and many other Ruby libraries, such as SQL, Rodoth, Tilt, Bracktest, eRuby, Warning, and mini test hooks. I'd say almost all Ruby web applications depend on at least one of these libraries, probably either Tilt, eRuby, or Bracktest. I'm one of the maintainers of Rack, and almost all Ruby web applications are going to depend on Rack. I'm Ruby committer. I was the primary implementer of keyword argument separation in Ruby 3. You saw the code example in the Sitepress presentation by Brad. I also implemented the keyword, the anonymous splat and keyword splat forwarding. He was showing in his example. These days, most of my work in Ruby itself involves on fixing bugs in Ruby. In a lot of cases, those are bugs I introduced in the first place. I am the author of Polished Ruby Programming, which was published a few years ago. So this book is aimed at intermediate Ruby programmers, and it focuses on teaching principles of Ruby programming, as well as trade-offs to consider when making implementation decisions. For 24 years, I served the people in the state of California, working in various information technology positions, most recently as the head of information technology for a small state department, where I served as the department's chief information officer, information security officer, lead programmer, lead systems administrator, and network administrator, and also the backup and help desk. However, I left public service last month to join Ubi Cloud as a principal software engineer. So at Ubi Cloud, we're building an open source alternative to Amazon Web Services. I now work with a great group of people, and I get to write and review Ruby code all day, and I'm much, much happy. All right, so I'm going to now dive right into a simple Roda example, just in case you're not familiar with it. And this example is a little bit more complex than Hello World, but it shows Roda's key advantage over other Ruby web frameworks, which is the ability to handle requests during routing instead of separating the routing process from the request handling process. So with Roda, all requests to the application are yielded to the route block, and the route block is responsible for handling all requests. Now, by convention, Roda uses R as the route block variable. At any point in the route block, you can do processing related to the request. For example, if you want to check access by IP, you can have that check at the top of the route block. And this would be equivalent to an application level before hook in other frameworks.
Now, assuming we pass the access check, we get to the first routing method. So the r.on method is used to handle branches in the routing tree. In this example, the r.on method is passed two arguments called matchers. The first is the string employee, which will match if the next segment in the remaining path is employee. And the second is the class integer, which will match if the next segment in the request path or the remaining path is an integer. So if we look at the combination of these two matchers, they will match a request path, such as /employee/7. And since the entire request path has been consumed by the two matchers, the remaining path is empty. The matchers will also match a request path, such as /employee/7/name, and the remaining path after this would be /name, which is what the routing methods inside the block will operate on. It would not match a request, such as /vendor/9, since the first segment is not employee, and would also not match a path, such as /employee/name, since name is not an integer. Now, if the request does not match the r.on call, r.on will return nil without yielding to the block. And in this example, it would reach the end of the route block, which results in a 404 response because the request has not been handled. Now, if the request does match the r.on call, it will yield to the provided block. And because the integer class matcher was used, the block will be yielded that segment of the request path converted to an integer. So for a GET request, such as /employee/7/name, the employee ID block variable will be the integer 7. Now inside the block, first line is this code, which shows the primary advantage of Roda, which is at any point during routing, you can do processing related to the request. Now in this case, we're using that employee ID block variable to look up the employee by ID, and then we're using that to set the employee variable. And all routes under this block can then access the employee. Now you can get similar behavior in other frameworks using before hooks, but this provides a simpler approach that avoids indirection. If you've ever had to debug issues involving the use of before hooks, I think you can appreciate this approach. Now, what if there was no matching employee for the ID? Well, in that case, you can use the next keyword to return nil from the block, which Roda will treat as a 404 response. Now that ensures there is a valid employee for the rest of the block. All right, so the next routing method is r.is with a string name matcher. Now r.is is similar to r.on, except that it requires that the request path has been fully consumed after all the matchers have been applied. Now for our request, since the employee and 7 segments have already been consumed, the remaining path is /name, and the string name matcher will match that segment. And since the entire request path has now been consumed by the matchers given to the routing methods, the r.is method will match, and it will yield to the block. Now inside the r.is block, the first method calls r.get, and this will match because the request being handled uses the get request method. Now the r.get block returns the string hello, followed by the employee's name. As the block returns a string, that string will be used as the response body. So let's see how a post request to the same path will be handled. Well, the path of the request will still be fully consumed by the matchers given to the r.on and r.is methods. However, the r.get method call will not match because this is a post request and not a get request. So r.get will return nil without yielding to the block. The next method call in the block is r.post, which will match because this request is a post request. And so r.post will yield to the block, and in this case, we will use the name parameter to update the employee's name, and then we will redirect the request. And since no arguments are given, this will redirect to the same path, but using a get request and not a post request. Now, hopefully this example was able to give you a basic idea for how Roda's routing tree works. The most important part to remember is that Roda gives you the power to do processing related to the request at any point during routing. And this reduces duplication and indirection and results in applications that are simpler and easier to understand. Simplicity is one of Roda's 4 goals. After 10 years developing Roda, I still think that the primary benefit of Roda is it allows the same application to be built more simply than in other frameworks. Another of Roda's goals is performance. Now, unlike the simplicity goal, which is subjective, you can see objective differences between the behavior or performance of Roda and other web frameworks. So we'll look at two benchmarks. The first is R10K, which is a synthetic benchmark that measures per request overhead and scalability for large numbers of routes. R10K benchmarks applications with 10, 100, 1,000, and 10,000 routes, and to avoid web server overhead, it tests using the Rack API directly. So here are the request per second results for Roda, Rails, Sinatra, Hanami, and Camping. And it shows that Roda is much faster than other frameworks. Now, unfortunately, the scale of the graph makes it difficult to see how the other frameworks compare. So to make it easier, here's the same graph, but using a logarithmic scale. So this still shows Roda is much faster, but it also shows that Roda, Rails, and Hanami all scale well for large numbers of routes. It shows that Sinatra and Camping do not scale well for large numbers of routes, and that's because both use a linear search of routes during request handling. R10K also provides memory benchmarks, and these show that Roda uses less memory than other frameworks. Rails uses about 3 to 4 times more memory than Roda in this benchmark. And I think the R10K benchmarks are useful, but they don't tell you much about real-world performance differences. For that, the Tech and Power web framework benchmarks do a better job. So Tech and Power has been benchmarking web frameworks in many languages for over 10 years, and Roda has led the Ruby web framework benchmarks ever since it was added in 2017. Now here are the composite score results for the most recent round of Tech and Power benchmarks for Ruby web frameworks, and Roda leads in every category. The weighted score for Roda is almost double the weighted score for Rails, and that lines up with results I've seen from applications converted from Rails to Roda, where the converted Roda application is about twice as fast. Now, as the benchmarks show, Roda achieves its performance goal. It's the fastest Ruby web framework, it scales well, and it uses the least memory. It's the fastest framework mostly because it has the lowest per request overhead. Roda is designed to minimize the amount of work between when it receives the Rack request environment and when it starts processing the routing tree. Roda scales well because it uses a routing tree. As soon as one branch of the routing tree is taken, other branches at the same level are no longer considered. And finally, Roda uses the least amount of memory because it is designed around a small core. And that small core handles basic routing and request handling. All other features are added via plugins. Roda's core is itself a plugin, and plugins can override any part of core Roda and any previously loaded plugins. As an example of its minimalism, Roda's core does not include template rendering. Template rendering is supported via a plugin. And it's common to use this plugin when you're developing applications that are targeting browsers. However, if you're designing an application that just serves API responses via JSON, you wouldn't need it. In that case, you'd want to use the JSON plugin, which allows your route blocks to return arrays or hashes and automatically converts those to JSON and uses them as response bodies. The reason I refer to Roda as a toolkit is you can think of each plugin as a tool, and different applications require different tools. And with Roda, you only pay the overhead cost for the tools that you choose to use. Roda ships with over 120 plugins to handle the needs of a wide variety of web applications, and there are numerous external Roda plugins to handle additional needs. So this approach of having a small core and shipping all the optional features as plugins is how Roda achieves its goal of extensibility. Roda's final goal is reliability. I think there are two aspects to reliability. The first aspect is internal reliability. This is how the library itself is kept reliable. And the second aspect is external reliability, which is how using Roda can lead to more reliable applications. So let's first discuss internal reliability. Roda tries to ensure internal reliability by having good test coverage. In my opinion, the minimum for having good test coverage in Ruby is 100% coverage. I have a saying, 100% coverage means nothing, but less than 100% coverage means something. At least it means you have code that is not being automatically tested. And in my experience, untested code is the most likely place that you will find bugs. Note that 100% coverage does not ensure robust code. You can have 100% coverage and still have bugs. You can be executing code and not checking for proper results. You could be using unit tests and no integration tests and not testing that the entire system works together. For Roda and other open source libraries I maintain, I consider 100% coverage as the starting point, not the finish line. I no longer release a Ruby library without 100% coverage. Now, when I started out developing Roda, targeting 100% coverage meant 100% line coverage. And after Ruby started supporting branch coverage, and simple code was updated to support branch coverage, I expanded that to also include 100% branch coverage. So coverage in Roda is tested before every release, and if for some reason it is less than 100%, appropriate steps are taken to get it back to 100%. Now, coverage isn't the only approach that Roda uses to ensure internal reliability. Another approach that Roda uses to ensure internal reliability is that it uses almost no mocking in its tests. Mocking in tests often leads to tests that pass but have issues in production, and avoiding them leads to more reliable tests. If we talk about cohesion or coupling, mocking leads to very tight coupling in your tests. It's one of the reasons it's bad. The final approach that Roda uses to increase internal reliability is it deliberately limits the libraries it depends on. Core Roda's only runtime dependency is wrap. Some plugins depend on additional libraries, but in general, dependencies are deliberately kept to a minimum to limit risk. So now that I've discussed how Roda achieves internal reliability, let me discuss how Roda achieves external reliability. Now, Roda combines two development approaches to achieve external reliability. Now, the first development approach is immutability. Roda applications are designed to be frozen in production and when testing, and this reduces the possibility for thread safety issues, as well as memory leaks due to unexpected object retention. Now, immutability is not just for reliability in Roda either. With Roda, immutability also improves performance. When you freeze your Roda application, Roda knows there'll be no further configuration changes to it. Roda then determines whether the methods that it has that are designed for extensibility have not been overridden. And in that case, it overrides the default extensible methods with optimized methods. And that gives you the best of both worlds: extensibility when you need it, and maximum performance when you don't. Second development approach related to reliability I refer to as pollution control, more explicitly namespace pollution control. Roda limits pollution of your constant method and instance variable namespaces in your application. All internal constants in the Roda class start with Roda to avoid conflicting with user-defined constants. Roda limits instance variable pollution by prefixing all internal instance variables in route block scope with an underscore. If you've ever developed a Sinatra application and tried to use request or response instance variables, you will appreciate this. Ask me how I know. Roda limits method pollution by only defining 6 methods in Roda block scope beyond the methods that are defined in object, and some private methods that begin with an underscore. And that makes it less likely that a user-defined method will conflict with a Roda method. So now I've given you a brief taste of Roda and discuss how Roda has achieved its goals. I can start discussing the first 10 years of Roda. So Roda's first release was on July 30th, 2014, and its most recent release, the 125th release, was last week. Now, I don't like waiting long to use new features, so Roda follows a simple to understand release schedule. There's a new Roda release every month, around the middle of the month, ever since 2014. I also don't like it when changes to a library break my applications, so Roda places a high priority on backwards compatibility. I think the compatibility is so good that the majority of applications that worked with the first release, Roda 0.9, would still work if you upgraded them to the latest release, Roda 3.86, with one main exception. If we go back to our first example, we see that it uses the integer class matcher. However, Roda did not support using the integer class as a matcher until Roda 2.27. Before Roda 2.27, this type of matcher would generally be written using what is referred to as a placeholder string, with placeholders in the string being prefixed by a colon. However, this style resulted in 2 issues. First, it resulted in redundancy. Most developers named their placeholders similar to the block variables. It's not technically a problem, but it is a tad annoying. The actual problem was a performance problem, which is that you needed to scan all of the strings that are used as matchers to see if the string contains a placeholder, and then treat the string differently if it has a placeholder. And strings are the most common type of matcher, so this check resulted in a measurable slowdown, even if you were not using placeholders. Now, Roda 3 removed support for placeholders from string matchers by default, and in order to support backwards compatibility, Roda 3 shipped with a placeholder string matchers plugin. I analyzed a couple of my open source applications, checking out the commit where the application was converted from Sinatra or Rails to Roda 0.9, and trying it with the current version of Roda. And in both cases, adding this placeholder string matchers plugin was the only Roda-related change necessary to get specs passing with the current version of Roda. Comparatively, Roda did even better than SQL, since there were generally 3 to 4 lines needed to be changed for the tenure application to work with the current version of SQL. I mentioned that one of the reasons for breaking backwards compatibility was to improve performance. So how much did this change and other changes improve Roda's performance over the last 10 years? Well, to determine that, we're going to look at some more R10K benchmark results to see how Roda's performance has improved over time. Additionally, Roda is a fork of another framework named Cuba, so we're going to compare Roda to Cuba. So we're going to start with Roda's initial release, compared against the current Cuba release at the time. And as you can see, performance is basically the same. For the initial release, I was focused on differences in route block handling block responses, and getting the plugin system working. I wasn't focused on performance, since Cuba was already much faster than other Ruby web frameworks at the time. Less than a month after the initial release, I released Roda 1.0, and that has had a massive boost in performance over the initial release, with a number of additional optimizations. At the time, most of the matchers in Roda were based on regular expression scanning, and the most important optimization was the caching of regular expressions instead of generating a new regular expression object for every matcher. About 6 months after releasing Roda 1.0, I released Roda 2.0, which improved performance over 1.0 by about 20%. This performance improvement was due to reducing allocations and operations during matching, so that each match attempt did not modify the request environment. About 2.5 years after that, I released Roda 3.0, which improved performance over 2.0 by about 40%. And this performance improvement was mostly due to avoiding regular expressions during matching and the removal of placeholders during string matching. Instead of regular expressions, string methods such as start with and index are used, and this idea was taken from Cyro, a routing library by the same author as Cuba. By January 2021, with the release of Roda 3.40, performance had increased another 15%. Now this performance increase was due to a couple of optimizations. During this time period is when I added the optimization during application freezing. Additionally, the performance of string and segment matching was improved by about 15%, and terminal matching by about 400%. Between Roda 3.40 and 3.60, performance increased another 30%. Now this was due to additional optimizations on the most common matchers. Roda's current performance is about the same as Roda 3.60. Between Roda's initial release and the current release, performance in this benchmark improved by a factor of 12. And I think that's pretty amazing, considering that even at Roda's initial release, it was one of the fastest frameworks. However, this is not the limit of Roda's performance. Using the optimized string matchers, optimized segment matchers, and plain hash response headers, Roda plugins, performance can be improved an additional 35%. This does require some small sacrifices in usability, though. All right, so R10K is a routing and per request overhead benchmark, and Roda has improved greatly over the years of those. That's not the only way that Roda has improved performance. Many of the plugins that ship with Roda have been optimized as well. For example, the render plugin has shipped with every release of Roda, but it and other related plugins were extensively optimized a few years ago. For simple templates, the render plugin is about 4 times faster than it was originally. Speaking of plugins, Roda 0.9 shipped with 15 plugins, and Roda 3.86 ships with over 120 plugins, more than 8 times as many as the initial release. So I'm going to take you on a quick tour of the last 10 years of Roda plugins. Now, in the initial release, in addition to rendering, Roda shipped with plugins for handling exceptions, customizing default headers and 404 responses, handling flash messages, streaming responses, and operating as rack middleware. However, one of the most important plugins was the ability to use separate routing blocks. If you remember back to our initial example, I mentioned that all requests are yielded as the route block, and the route block determines the response. Now in Ruby, you cannot split a block across multiple files, and having all routes in a single file only makes sense for small applications. To handle large applications, you need a way to separate the routing block. And even the very first release of Roda supported that via the multi-route plugin. So with the multi-route plugin, you would call r.multiroute in your main routing block, and it would dispatch the separate routing blocks based on the next segment in the remaining path. And those routing blocks would generally be stored in separate files based on the route segment name, like this. And that made it simple to organize large applications in Roda, and allowed even the first release of Roda to scale from simple single-file applications to decent-sized applications. Roda 1.0 added 11 new plugins not in the initial release, and these included plugins for returning arrays and hashes as JSON, cross-site request forgery protection, rendering a collection of partials in one call, and having a separate view subdirectory for separate branches of the routing tree. Additionally, the render plugin was expanded to support the automatic escaping of output and templates, greatly reducing the likelihood for cross-site scripting issues. I think my favorite plugin addition 1.0 is called Symbol Views. So the Symbol Views plugin is very simple, but it allows you to replace manual calls to view to render templates and just have the route block return a symbol. Now, this small change dries up a lot of route code, makes the common case of rendering a template inside a layout even simpler than it is in Sinatra, essentially Rails. Now, not everyone is a fan of this terse style, but just because I think a particular style is nicer doesn't mean I think I should force it on all Roda users. Between Roda 1.1 and 1.3, 25 more plugins were added, including plugins for managing HTTP caching, incrementally rendering templates, compiling, compressing, and serving asset files. Roda 1.2 added the mailer plugin, which brought the benefit of routing trees to sending emails from applications. So here's an example that uses the mailer plugin. Generally, use the mailer plugin in a Roda subclass designed specifically for sending emails. Unlike a Roda web application, which is designed to handle HTTP requests, a Roda mail application is designed to handle internal requests. However, sending mail with the mailer plugin is done by providing a path, just like with an HTTP request. A Roda mail application uses the same basic routing methods that a Roda web application uses. And just like in a Roda web application, at any point when handling a mail request, the Roda mail application can do processing related to building the email. So here we're setting the sender and recipient addresses, so those don't need to be duplicated inside every mail handling block. The r.mail method is used to handle mail routes, and it operates similarly to r.get and r.post. In this case, the time-off matcher matches the remaining path. The method will yield it to the block, and the block sets the subject for the mail and returns the symbol for the mail template to render. And returning a symbol works because this mail plugin also uses the symbol views plugin. And between Roda 2.0 and 2.29, 22 more plugins were added, and these included support for setting preload headers for assets, serving public files at a specific place in the routing tree, rewriting paths prior to routing, parsing JSON request bodies to parameters, fast O1 routing to static paths, and having the routing tree support file extensions in the request path especially. Roda 2.27 added a class matchers plugin, which allows you to specify the handling of arbitrary classes that are used as matchers. Going back to our initial example, we see that we are using the integer matcher, which yields an integer, and we are then looking up the employee using that integer. I have to manually handle the case where that lookup fails. So using the class matchers plugin, we can simplify this. We can register the employee class as a matcher and build on top of the integer matcher. If there's a match by the integer matcher, the value is yielded to the block as an integer, and the block can then do the employee lookup. And that allows the routing tree to be simpler. Every case where you're trying to match an employee, you can pass the employee class as a matcher, and it will yield the employee object to the routing block if the segment was for a valid employee. And if the segment was not for a valid employee, it just wouldn't match. Between Roda 3.0 and 3.29, 12 more plugins were added, including support for encrypted sessions, early hints, content security policies, processing incoming emails using a routing tree, logging in common log format, showing nice exception handling pages in development, splitting the routing tree into subtrees without using regular expressions, and supporting stronger cross-site request forgery protection using tokens specific to the request method and path. Roda 3.3 added a typecast params plugin for handling the typecasting of submitted parameters to expected types. So here's an example of use showing the automatic conversion of a given parameter to a positive integer, ensuring that attackers cannot try to submit an array or hash. Typecast params has support for nested parameters, typecasting arrays of values to expected types, and custom parameter types. It's designed to be simple and not verbose. Between Roda 3.30 and 3.59, 17 more plugins were added, and these included support for host authorization, trying multiple render engines and multiple view directories when rendering templates, using arbitrary objects as matchers during routing, supporting multiple directories for public file serving at different places in the routing tree, and a simpler approach to dispatching separate routing trees, which can automatically set the view subdirectory during the dispatch. Between Roda 3.60 and the current version, 3.86, 19 more plugins were added, and these plugins included support for handling arbitrary objects returned from route blocks, auto-loading hash branches in development for faster development and testing, setting permissions policy, enforcing cookie flags, handling invalid request bodies, and measuring line and branch coverage of templates, even in Ruby versions that do not support coverage for eval code. Roda 3.79 added an HMAC paths plugin, which allows you to easily prevent path enumeration by including an HMAC in the path. Going back to our initial example, we see that this allows anyone to issue requests for this branch. So what if you want to prevent someone with access to the application from enumerating your employees? By using the HMAC paths plugin, you could wrap that routing block in r.hmac path. And when generating paths in your application, you would call the HMAC path method with the path, and it would prefix an HMAC and some metadata such that r.hmac path will consider it valid. So the HMAC paths plugin was expanded in Roda 3.80 to support session-specific HMACs, so that paths valid for one logged in user would not be valid for a different logged in user. And it was expanded again in Roda 3.81 to support paths that are only valid for a limited time. So that's a brief tour of plugins that Roda has added in its first 10 years. I want to finish up this presentation by briefly discussing 3 open source applications that are built on top of Roda and how they are using Roda's features. So the first application is Kafka Web, which is a web front end for Kafka, a Ruby gem for working with Kafka, a distributed publish subscribe queue. Now, Kafka Web ships with all of its asset files inside the gem. It uses Roda's public plugin, and it serves the assets using a path based on the gem version. And this automatically handles cache and validation by using a new path for each gem version. Kafka Web uses the custom block results plugin, so that route blocks can return Kafka Web specific objects, which are translated into HTTP responses. And this reduces duplication inside the route blocks. Second application is UbiCloud, which is the main application I work on. As I mentioned earlier, UbiCloud is an open source alternative to Amazon Web Services. UbiCloud uses the Rodoth authentication framework to handle authentication. Rodoth is Ruby's most advanced authentication framework, with built-in support for multi-factor authentication, such as TOTP and WebAuthn. Now, Rodoth is a Roda plugin, but you can use Rodoth even in non-Roda applications by using Roda's middleware plugin and using the Roda application as middleware. Well, UbiCloud uses multiple Rodoth configurations, as it uses Rodoth to handle authentication both for browser logins as well as for its JSON API. Now, this is the section of UbiCloud's main route block. It's designed to handle browser requests and GitHub webhooks. UbiCloud is a decent-sized application, so it uses the hash branches plugin to separate the routing trees. It actually has 2 separate dispatches to routing trees here. This one is for the main application, and it's used for logged-in users in browsers. Webhooks dispatch to a different set of routing trees because they don't need cross-site request forgery checks, nor do they require the same authentication as logged-in users. Well, this type of setup is possible in other frameworks, but I think it's significantly simpler in Roda. So the third application is Bridgetown, which started out as a static site generator. It can now do both static site generation as well as being a full stack framework. But Bridgetown uses Roda to handle routing. So here's the routing tree for Bridgetown server. It loads the Bridgetown server plugin, and all requests to the application use the Bridgetown routing method. So what does the Bridgetown server plugin do? Well, one thing it does is it loads a bunch of other plugins. Most of these are plugins that ship with Roda. A few of these are plugins specific to Bridgetown. For example, the SSG plugin is a Bridgetown specific plugin for serving the statically generated files. It's based on Roda's public plugin, but it automatically tries multiple file paths in order to allow for nicer URLs. That brings us to the r.bridgetown method. That method is defined by the Bridgetown server plugin. This method is running request scope. So it first initializes some Bridgetown specific code in route block scope. And it's configured with a base path. It tries to remove the base path from the requests, and then it tries serving the statically generated files. If there is no statically generated file related to the request, then it goes through all of the dynamic routes using Roda's routing methods. Now this had a bit more redundancy than I'd like. So a couple days ago, I sent them a pull request to change it to this, which has equivalent behavior. And the pull request was quickly accepted. I think this change shows a good job of showing the power of Roda, because you can run any code that you want at any point during routing. You can use any Ruby code you're familiar with to dry up your routing code. So that's how some production open source applications are using Roda to simplify their web development. As we get to the end of this presentation, I'm happy to announce that after 10 years, Roda recently passed 10 million downloads. So if you haven't already started using Roda, now is a great time to start. Have good fun learning about the first 10 years of Roda. That concludes my presentation. We have time for questions.
You have the mic? Oh.
Yeah.
So obviously, web frameworks, web toolkits are right in the middle of the attack surface for, you know, all the different kind of things that bad people are trying to do on the internet. You mentioned a bunch of features for like adding, you know, cookie encryption and HMAX and like offensive things that you're doing to reduce that. But presumably you also get like people saying, hey, I found a bug in Roda and it has security implications. How do you think about that as a maintainer?
Yeah, certainly security bugs are going to be the most important bugs to fix. I want to say I think Roda has had 1 or 2 security issues in the time I've been maintaining it. I'd have to look through the change log and see. It's certainly been a number of years since someone was reported a security issue in Roda. Yeah, certainly if one comes in, that's treated with the highest priority.
Sure. Does that kind of shortcut the monthly release process or try to keep it?
Oh, yeah, certainly. So in general, because Roda is released every month, I don't generally do point releases. There's only 2 reasons to do a point release. One is security issues. The other is fixing regressions from the previous release. So if there's a regression from the previous release, that will get a bug fix at like 0.1 release. If it's a regression from more than 1 release ago, then it usually waits till the next release.
Makes sense. Thank you.
Thank you.
Hi, thank you for the talk. First of all, it's getting dangerously close to my bedtime, so forgive me if this is a terrible question, but one thing I wanted to understand better is it's very clear, given the way think about the routing being hierarchical and processing happening as part of that. Is there any built-in caching that happens for, let's say, when part of a route is handled? So in the example, you pull up the employee. Is that cached for all other routes that spawn off of that, or is that not?
Let me go back to the initial example so you can go through this. So one of the things that makes Roda, Cuba, Cyro different than other frameworks is that this is really what you could call instance-based routing. There's no caching at all. Every request comes into the route block. There's not really any caching that's going on here. Everything just goes through. The reason it's fast is because it's very low overhead. That's not because there's any fancy caching going on. I wouldn't say there's none because like the render plugin does extensive caching to speed things up. But for the general routing part, there's not much caching that goes on. If you use regular expressions, those are like sort of converted in cache. And back when everything was regular expression based, the caching was very important. But now that pretty much everything just uses string methods, let's say everything. Like I think the integer class matcher uses regular expressions internally that are cached. So that's one thing where caching is important. But for general things like the employee and name part, those just use string methods. So there's no really caching need for it. It's just fast because string methods are fast.
I'm glad I wrote the slide because I have a question about this next and less.
Okay.
I was actually looking at this code the other day trying to figure out what's going on there. Is that inside of a loop? And I noticed in another slide for mail, it was like a bang method. I assume that raises an exception. And I think another plausible way of dealing with this is just like a return unless. So I'm really curious, like, Why the next? Why not a return or raising an exception?
So return would theoretically work in this case, but only because the route block is technically used to define a method for performance reasons. It was originally done that way. Originally, it was just an instance eval block, in which case return wouldn't work because you can't return out of a regular block. It was changed to defining a method. This was back when Ruby instance evaluating, basically old versions of Ruby, if you instance eval a block, it would create a singleton class, which is a very slow thing to do. So one of the things that Roda did to work around that is it took most of the blocks, like the route block, and defined them as methods, which you don't need to define a singleton class for, you can just call. So that was a performance thing. So return would theoretically work here, but only because of the way that the route block defines a method. What next does here, next in any block, doesn't have to be a loop. Next in any block sort of jumps to the end of the block. And in this case, because no argument is given to next, it's really like next nil. So basically, this is a quick way to return nil from the block. So the way Roda's routing works is every time you get into a block, sort of that block takes over. So like if you don't do anything to the block, it comes to the end, and that's when it does, it also will return a 404 response. But like, let's say it goes down here, it yields to this block, yields to this block, yields to this block, and this returns. Now it doesn't go past this. Once this block returns, once you get the final inside routing method and the block returns, it throws the response. So it jumps all the way through. You don't need to worry about return things. Technically, this is how Sinatra works as well. So when you have a Sinatra block, it ends up throwing, and there's basically a catch thing at the end surrounding the request. That's why things like you don't need to worry about like double redirects or double renders in Roda, because let's say you have r.redirect if something, you can have code after that, because if the redirect happens, that throws. So you can never have someone where you redirect and do something else, because the redirect ends the processing at that point and throws the response directly to the user.
Was there any like performance issues with throwing?
No, throwing in Ruby is actually very fast. It works similarly to how exceptions work. And you think of exceptions as slow, but the slow part of exceptions is not the throwing part. The slow part of exceptions is building a backtrace. That's what makes Ruby exceptions slow. The actual catching and throwing of stuff is actually very fast.
I do have another question about pattern matching.
Okay.
I worked with a lot of case-in, and I'm curious, like, are you using pattern matching in case-in here, potentially even with RVS? Or is that just like, it seems like it'd be a different thing than Roda. I'm curious if you're thinking about that. Like, have you built an OO router that's using Ruby pattern matching?
Yeah, I've not done anything with pattern matching. Pattern matching in Ruby is cool, but it's also not very fast. Other thing is, people ask me why I do this, but Roda actually still reports Ruby 1.9 all the way to Ruby 3.4. So it has a incredibly wide range of versions it supports. But I think the main reason it's not used is it's just not very fast. And we don't really need to use it. There's always ways you can do things without using pattern matching. It makes some code nicer, but there's a lot of cases where it's, I'd say, overused.
Thanks. Right. I'll pass it over there.
Quick question with a possible long answer. What was the original motivation for Roda, given it's only 10 years old?
Thank you for the question. So the original idea here is I was a Rails programmer for a few years, from like 2005 to about 2008, and then Sinatra came out. I love Sinatra. I was a Sinatra programmer for a long time. But I got to the point where Sinatra, because every route is separate, you ended up with a lot of duplication in your routes. That's in 2014, I discovered Cuba, and Cuba was this hierarchical approach where you could reduce duplication in all of your routes. So I originally contacted the Cuba guys, and I'm like, yeah, I really like this, but I don't think it's as nice to use as Sinatra. And they were like, well, it is what it is. We're not going to change it, which is fine. So that's when I forked it, and the original name for Roda was Snuba, half Sinatra, half Cuba. So I changed it to Roda. Roda, the name Roda comes from a video game where Roda is this big all-knowing tree. So that's why Cuba didn't even call it a routing tree. Routing tree is something that I came up with, and that's why it's called Roda. But that's the original thing. It's like combine the best aspects of Sinatra with the hierarchical routing tree from Cuba. That's sort of how it is.
How does like YJIT or anything of like with the just-in-time compiling stuff that's come out in Ruby recently, does that affect the performance or any of the benchmark comparisons that you were showing?
Yeah, so when I benchmarked with YJIT does a good job. I think for the 10 and 100 route thing, it makes it significantly faster. I think when you get to the 100, the 1,000 and 10,000 routes, it actually makes it slower because the blocks get so humongously gigantic that YJIT does not do a good job optimizing at that point. But for reasonable stuff, YJIT will definitely speed up your Roda app. It provides a bigger speed up to Rails apps because Rails apps are less efficient to begin with.
First, thank you for your effort here. And there was a question about all the work maintaining so back from 1.9. I mean, it's huge.
So the question is, why bother supporting Ruby 1.9? And I get that question. I get that question quite often. So that my idea here is it's not that difficult to support. I'd say it's kind of annoying because there's newer things in Ruby, things that could improve performance slightly. A lot of just nicer things. Like it'd be cool to use 2.3's lonely operator to simplify code. But the main reason I do it is, let's say you have an old Rails app or an old application you want to upgrade. You can convert, assuming it's running Ruby 1.9. Early versions of Roda actually supported Ruby 1.8. Even back in 2014, that was considered kind of ridiculous. But you can, as long as it's done in 1.9, you can actually go convert it to Roda and then jump directly from 1.9 to 3.3. And obviously, if there's other things it's using, they probably won't do a big jump. But Roda and SQL actually, pretty much most of my libraries will go support all the way back to 1.9, so you could convert and then upgrade in one go from Ruby 1.9 all the way to 3.3.
Right. Who's with me and wanting so much to try out Roda now? Yeah, so this is incredible. Thank you.
Thank you very much.
All right, I'm gonna ask Academia's team. Come over. Jamie, come over. Come over and yeah, let's just say thank you to the team who put this all together. And yeah, please,
Applause.
Thank you for having the Ruby Meetup event here at Academia, and I really want to thank Rob and Attilio, who are part of the recruiting team, for helping set up the event, as well as our facilities manager, Michael, who's all the way back there, as well as Minnie and a few other folks who are colleagues who are within the crowd here right now. Huge thank you for everyone attending. If you're interested in talking a little bit more about what we do here at Academia, please see us afterwards and we can tell you a little bit more about what our platform does. Thank you.
Don't forget, on the back of those cards, there's a QR code and it leads to the job openings at Academia. Who's advertising it? All right, thank you guys. So with that, this is we're finalizing our program. Don't forget to sign up at Luma /SFRuby for our next events, and we can stay here we can have this till 9, and yeah, if you want, we can later grab a drink somewhere unofficially. Yeah, but yeah, so that's so thanks so much for coming again. See you next time. Thank you.